Alright folks, welcome back to the final math notes of chapter 8. We're going to be looking at factoring sums and differences. We have a couple special cases that will make factoring higher degree polynomials a little bit easier for you. Right now I'd recommend you go ahead and pause the video and write down these three equations and come back once you have those written down. Alright, now that you're back, let's take a look at some examples from each of these. So difference of squares. I'm going to do a little zooming in here. Looks like that. Let's do a little example. Easy one right away would be something like you've done in the past, which might be like 25x squared minus 9. You should recognize that those are perfect squares. And if I rewrote them in this format so that you had a squared minus b squared, that would be 5x squared minus 3 squared. So then my a would be 5x, my b would be 3, and I can just follow this format. So a plus b would be 5x plus 3, a minus b would be 5x minus 3. That would be the factored form. If I wanted to know the roots, I could make it equal 0. And for this one, get x is equal to negative 3/5 and x is equal to positive 3/5. Okay, let's look at another less obvious example. What if we had (16x to the 4th minus 81? Well, once again, if I rewrote that, that would be the square root of 16x to the 4th would be 4x squared minus 9 squared. So this would be my a, this would be my b. So I get 4x squared plus 9 times 4x squared minus 9. But I haven't finished factoring this out yet. And what I should notice now is that I have another difference of squares in that second factor. So if I take that second factor, I can do another set of difference of square equations on it. This would be the same thing as 2x squared minus 3 squared. So I can break this factor down into 2x plus 3 times 2x minus 3. Because this would then be my a and my b, and this would be a plus b times a minus b. Now, I haven't fully factored the equation yet because I have that 4x squared plus 9. And if I only factored it to the reals, then I would be done, but let's keep going. If I set this equal to 0, then I have 4x squared plus 9 equals 0, so 4x squared equals negative 9. X squared equals negative 9/4. Take the square root of both of those, and I end up with plus or minus 3/2 I, because we have that negative square root in there. Then, if I take x equals 3/2I, and I multiply everything by 2 and subtract over my 3i, then I will find that my roots are 2x minus 3i for that. And if I did the same thing for the negative solution, then I would get 2x plus 3i. So the fully factored form would be 2x minus 3i times 2x plus 3i times 2x plus 3 times 2x minus 3. Okay, but difference of squares certainly helped us do that a lot faster than we otherwise could have. All right, let's take a look at some of these other examples here. Sum of cubes. Sum of cubes tells us we have two perfect cubes that are being added together. So a simple example of that would be something like x cubed plus 27, which we could rewrite as x cubed plus 3 cubed. So my x would be my a, 3 would be b, and I can just substitute x and 3 wherever there's an a and b. So this becomes x plus 3 times a squared would be x squared minus a times b would be x times 3 or 3x plus b squared would be 9. And then I would need to use quadratic formula to factor this one out a little bit more. But that gets you through the first stage of factoring without having to do long division or go through your Q over P checks to figure out what factors are. Let's look at another one. With difference of cubes. Oops. Very similar to sum of cubes, just some sign changes from the other formula. So if we had something like 8x cubed minus 64 then we should recognize that as 2x cubed minus 4 cubed. Wherever there's an a, we can put in 2x. Wherever there's a b, we can put in 4. So then this would be 2x minus 4. A squared would be 4x squared plus 8x plus 16. And then to go further, we would probably want to go ahead and go back to quadratic formula. It does look like in this particular example, we might be able to just factor out a 4, which would help us out as well. So I would probably rewrite this as 4 times 2x minus 4 times x squared plus 2x plus 4, since each of those terms is divisible by 4. All right, guys. Hope that helps.